Hey everyone, welcome to 3.6 Complex Numbers Notes Part 2. We already did one part on Monday. We're going to do the other part today. We're still going to be talking about the same type of stuff. There's more things to talk about with complex numbers, more than I can fit in one lesson. As a little recap, I is the imaginary number that allows us to find the square root of negatives. These answers aren't going to show up on a graph because they are imaginary, but they are still solutions to the problem. And a lot of engineers and things like that use these answers. The most important powers are that I itself is the square root of -1. So anytime you see a negative inside of a square root, when you simplify it, there's going to be an I squared is -1 because basically you're just squaring it and taking off the square root. So you need to for sure know these two things. There were other powers we talked about in the first video. These are the two most important that you absolutely need to know. We're going to use the second part, the fact that I squared is -1, a lot in this lesson. The first thing we're going to look at is multiplying them. So, as you're multiplying complex numbers, I want you to keep these things in mind. First, distribute as if the i's were x's. So kind of treat them like variables. They're not variables because they actually stand for the square root of -1. There's a specific value assigned to them, but you can treat them kind of like they are variables. Once you've distributed, you're going to combine your like terms. And then this third part is where I said we're going to use that I squared a lot today. Whenever you see an I squared in a problem, get used to changing it to -1. Because if we can change I squared to -1, why wouldn't we? Because -1 is a way easier thing to have in a problem than I squared. Because it's the letter I, first of all, and second of all, it's got an exponent on it. And then the last thing we're going to do is write it in a plus bi form. That just means that the real part goes first and the I part goes second. So let's take a look at our first example. We have -2i times 7 plus 4i. So I'm going to take that -2i and I'm going to multiply it. Like this. And -2i times 7 is going to be -14i. -2i times 4i is going to be -8, and then I times I is I squared. So if you multiply two things that both have an I together, that becomes I squared. Just like x times x is x squared, I times I is I squared. Then we've distributed. There are no like terms, so we're going to skip step 2. We're going to go straight to step 3, which is change I squareds to -1. So I'm going to replace I squared with -1. Okay, that's what I'm talking about there. Really not that difficult, just make sure you don't forget to do that. But then, that means that this is just -8 times -1, which is +8. And then the very last thing I'm going to do for this problem is to write it in the correct form. The -14i should go second. Be very careful because the negative goes with the 14i, not the 8. So the 8's still positive. It's the 14i that's being subtracted because it's negative. And that's your final answer. Let's look at another one. This one's going to have a few more pieces to it. This one has 2 sets of parentheses. Don't freak out when you see problems like this because all that means is you're going to take this 9i and multiply it times I and times -7. And that's going to give you 9i squared minus 63i. So 9 times I is 9i squared, 9 times -7 is -63i. Then you would do the same thing, but with the 2. 2 times I is 2i. 2 times -7 is -14. So you take the first number and multiply it by both of the ones in the other parentheses, then take the second number and multiply it by both of the numbers in the other parentheses. This one does have like terms. They are right here, my two i's. So I'm going to go ahead and add those together. Negative 63 plus 2 will be negative 61. And at the same time, I'm going to go ahead and change that I squared to negative 1. And then I added these two together to get negative 61. Nothing changed about the 14. Then this is actually negative 9. Should be a negative right there. Okay, I went back and fixed that for you. And then what we're going to do last is we've got negative 9 and negative 14. We're going to add those together. Negative 9 minus 14 is negative 23, and the negative 61i goes last. One more, just for good measure. 2 minus 3i squared. Now, when you square something, you are multiplying it by itself. Don't just square both of these things, because this is supposed to be 2 minus 3i times 2 minus 3i. So you just have the same parentheses twice. And what's going to happen is I'm going to do the same thing I just did. 2 times 2 and 2 times negative 3i is going to be 2 times 2 is 4. 2 times negative 3i is negative 6i. Then I'm going to do the same thing, but with the negative 3. Negative 3 times 2 is negative 6i. Negative 3i times negative 3i is 9i squared. And then I get to add these two in the middle together. Be very careful. Some people think that they cross out, but they don't, because negative 6 plus negative 6 is negative 12i. And I'm changing this I squared to negative 1, which really makes this last number negative 9. And then I can add together the 4 and the negative 9. 4 minus 9 is negative 5, and the negative 12i stays at the end. All right, and then the last thing that we're going to talk about, or I guess there's two more things. The next thing that we're going to talk about is that we can solve equations that ask us to find the values of x and y to make it true. And what you're going to do is focus on the real parts and then the imaginary parts. For the real parts, I'm talking about the ones that don't have an I with them. So this part and this part. 8x has to equal 16 because everything else has an I with it. So we have to solve the equation 8x equals 16. Divide by 8 on both sides, x equals 2. And then you're going to do the same thing but for the imaginary parts. So kind of view each problem as its imaginary and real parts as two separate things. So 12i has to equal negative 3y. We don't really care about the fact that there's an I there, because that's really what told us to match these two parts up. We just care that 12 has to equal negative 3y. And then I'm going to divide by negative 3 on both sides, and that gives me y equals negative 4. So x equals 2, and y equals negative 4. Okay, and then the third and final thing we're going to learn about complex numbers is how to do something called rationalizing the denominator. Let me get rid of all my drawings. So basically what's happening here is we don't want there to be an I in the denominator. We want it to be on top like it has been in every problem so far, okay? And to get rid of it, what we're going to do is multiply by the conjugate. The conjugate is the same expression as the denominator, except for you're going to change the sign only of the imaginary part. So, for example, I would want to multiply this one by 2 minus 3i. So instead of 3i, it's negative 3i. And I have to do that on the top and the bottom. Okay, so it's the conjugate of the denominator. So I'm looking at this part and just changing the sign in the middle pretty much. And I have to add it to the top and the bottom. And then I'm going to distribute and simplify. Okay, so I got rid of my drawings, and now I am going to show you what this looks like when we're actually multiplying it out. All I did was I took the bottom of this and I changed the sign in between to a minus, and I multiplied by it on the top and the bottom. So on the top, I have to do 12 times 2 and 12 times negative 3i, which is 24 minus 36i. On the bottom, I have to actually FOIL this all out. So I'm going to start with 2 times 2 and 2 times negative 3i, which is 4 minus 6i. And then I'm going to do the same thing with the 3i times 2 and 3i times negative 3. 3i times 2 is 6i. 3i times negative 3i is negative 9i squared. And what you're going to notice is every single time you do this, and the whole reason why we had to just change the sign in the middle, but leave everything else the same, is these two in the middle cancel. Negative 6i plus 6i is 0. That's what you want to have happen, because now the i's are gone. Because over here, this is I squared, and I squared is negative 1, making this actually equal to a positive 9. So the top part is 2 minus 36i. The bottom part is 4 plus 9, or 13. Okay, now I'm going to do this one over here. The bottom part is 1 plus 9i. So I need to multiply by 1 minus 9i on the top and on the bottom, like that. Now, this time, both of them need to be multiplied out. So 4 times 1 and 4 times negative 9i becomes 4 minus 36i. Then I do the same thing, but with the negative 5 times 1 is negative 5i, and negative 5i times negative 9i is positive 45i squared. Notice how those two negatives multiply to a positive. Okay, then what I'm going to do is the bottom part. So on the bottom, I have 1 times 1 is 1. 1 times negative 9i is negative 9i. And then I'm going to do the same thing, but with this 9i multiplied by 1 is 9i, and 9 times negative 9 is negative 81i squared. And you'll notice that in the middle, those are going to cross out again. That's always going to happen. But before I get there, I'm going to go ahead and add my i's together in the middle on the top. Negative 36 minus 5 is negative 41i. I'm going to go ahead and erase that so you can actually see it. And then I'm going to change this to negative 45 because I squared is negative 1. On the top, I'm now going to combine my 4 and my negative 45, which is negative 41. And then the negative 45i is going to go afterwards. So it takes a couple of steps and a little bit of work, but it's not overly complicated. The only difference between this and what we were just doing is you have to multiply on top and on bottom. So a lot of steps, yes. Extremely difficult, no. It's just going to be tedious. On the bottom, the 2 in the middle cross out, and this negative 81i squared is going to turn into positive 81 because the I squared changes the sign, basically. And I have 1 plus 81, which is 82. And there you have it.